All right, now we're on to the ambiguous case. What does that mean? So let's look at dictionary.com's definition of ambiguous. So ambiguous, open to or having several possible meanings or interpretations. All right. Yeah, that works. So, okay. What does it mean? Well, it means that we're going to have either one, two, or no solutions to the triangle, depending on certain ratios. So when does the ambiguous case occur? Well, it occurs, we talked about this in the very first video of law of signs, when we have side-side angle. Now, here is the book definition of how do I know how many solutions I'm going to have. Well, you can look at this and you can study it, and you should be able to understand it, actually. But really, I wouldn't memorize it by any means. There are problems where it could be helpful, and you'll see some of those problems in the book. But during those problems, you can actually just kind of figure it out if you think about it. But we can have one, two, or no solution. Here's a demonstration of that. So let's look at this real quick. Okay, so here you see two triangles that are exactly the same. Angle A, side AB, side BC, angle D, side DE, side EF. Okay, but now as I extend this, watch what happens. So now, look, right there, boom, right there. Oh, there. Okay, so see what's happening is there are two triangles now that have the exact same given angle, opposite side, and adjacent side. Okay, and so that's how the two triangle scenario can possibly work. Now the other side angle, other side and two angles will not be the same. So this angle right here, angle B, is not the same as angle E, and angle C is not the same as angle F. But A is the same as D, and BC is the same as EF, and AB is the same as DE. Okay, so that's how the two triangle scenario works. But there are restrictions on it. So that's what these restrictions are referring to. Again, I'm not really going to go through those. I'm going to explain to you how I would do these problems. But first, I want to emphasize this is for if you are given an acute angle. So whenever we have the ambiguous case, we're given two sides and an angle. So if that angle is acute, these are the possible outcomes. I want you to think about what if the angle A, or the given angle, is obtuse. And keep in mind, it doesn't have to be angle A. That's just kind of more for generic purposes. What are the possible outcomes and restrictions on those outcomes? So I want you to think about that. Pause the video, think, and unpause when you're ready to move on to problems. Alright, so now let's move on to see some examples, and I'll explain how I would do these problems. So here I'm given side, angle. Alright. Now the nice thing about the ambiguous case is there is only one option for what you could try to solve for first. So the way I would approach these problems, and this is me personally, is just go ahead and solve it. Because if you have the no solution scenario, you're going to figure that out pretty quickly. And if you get one solution, then just assume that there's two, and you'll figure out pretty quickly if there actually are two. And it's not going to be that much more work. But personally, I think it's much easier than trying to think about ratios of sides compared to the height and things like that. Because that means you have to find the height, which is just another wasted step. So in this case, I have angle A, side A, and side B. So let's go ahead and find angle B, since that is the only thing I can find. So sine of B over 14.3 equals sine of 17 over 5.8, which then goes to 14.3 sine of 17 over 5.8 equals the sine of B. So I can type this into my calculator, do sine inverse. For the sake of time, I'm going to just tell you that angle B equals 46.124 degrees. Okay, so since angle B worked, I have one solution. I know that now. Okay, if this didn't work, by not working, I mean if this value comes out to be something larger than 1 or less than -1, or just if you type it in the inverse into your calculator and it gives you a domain error because that's larger than 1 or less than -1, then it doesn't work and you don't have a triangle. Okay, so since it worked, I'm going to now assume that there are two solutions. spoiler alert, there are going to be for this. To start the second solution, I'm going to find what I call B prime. So it's the other angle B. So B prime is always going to be the supplement of the first angle you found. So 180 minus 46.124. Now, think about, so if I look at this picture again here, what I'm saying is angle C in this diagram is the supplement of angle F, and vice versa. You can prove that to yourself. I'm going to say that for you. For right now, if you don't believe me, or you're just going to have to trust me is what I'm saying. So then I get the other angle B, so B prime, is 133.876 degrees. Okay, so now I have an angle B and an angle B prime. Now at this point I'm going to just do two parallel solutions. And I'll find out pretty quickly if, okay, let me back up a sec. So B prime, if angle B exists, B prime will exist. This doesn't tell me that the second solution actually exists. The second solution is going to come from finding the third angle. So now I know angle C prime is going to be 180 minus 133.876 minus 17, because remember that was the given angle, so that's true for both. So angle C prime is 29.124 degrees. So this right here, since that worked, and by worked I mean it gave me a valid angle, that tells me that the second solution actually exists. So now I just continue solving both solutions. So angle C over here, 180 minus 46.124 minus 17. So angle C is 116.876 degrees. And then now I just have to find side C for both of these. So I can do little c over sine of 116.876 equals, and I'm going to use the givens of 5.8 over, the sine of 17. Doing algebra and using my calculator, little c equals 17.695 degrees. I'm sorry, that's not degrees because this was a side. Just 17.695. And then little c prime. So little c prime over the sine of 29.124 degrees equals 5.8 over the sine of 17. Solve for little c prime, and I get little c prime is 9.655. So again, the process there was just assume that you have at least one solution and go ahead and try to find it. I found an angle B that worked, so therefore the one solution is going to exist. Most likely. Now again, when we find angle C, it could have turned out to be invalid, but we would figure that out pretty quickly. So then I'm just going to assume that there's a second solution. So I find the supplement of the original angle that I found. That is always going to exist if the first angle found worked. But then when I find the third angle, that's when I'm truly going to figure out, okay, do these triangles exist, and how many solutions do I have? So since both of those work, then I can find this third side of each. So what I want you to do now is go ahead and do the second and the third problems, and I will give you a hint, those are not going to have two solutions, but try and you'll see. So that, go ahead and try it and see where it fails, and that will help you understand, okay, why that didn't work. So pause the video and do both of those. Unpause when you're ready to check. Alright, so over the middle one here, again, I just tried to find angle B right away. So I did sine of B over 20 equals sine of 76 over 18. And then when I solved for angle B, I saw that the sine of B was 1.078. So I just stopped right there, because since this number is larger than 1, I know that the sine inverse will not exist, because it's outside of the domain of the inverse sine function. Now, if I didn't recognize that, if I typed in sine inverse of 1.078 into my calculator, I'm going to get a domain error. Therefore, this is no solution. I'm done with the problem. For the next one, Here, again, I just solved for angle B right away, and I got angle B is 25.089 degrees. Let's put a little degree symbol on that. And then I found B prime. So so one solution did exist. So then the second solution, of course, I'm going to find B prime. B prime was 159.911. But then when I tried to find C prime, notice that I'm going to get a negative number. So as soon as I realize that, then the second solution doesn't actually exist. So I did a little bit of extra work to see that, but it was not challenging work. You're just doing a supplement and then subtracting two numbers from 180. So you should figure it out pretty quickly. But my one solution did exist. So then I continued on with angle B. I found angle C. So this was 96.911 degrees. Then I found little c, and I got 23.412. So I solved, so that triangle had one solution. Alright, ambiguous case, it occurs when we have side-side angle.